Hello everyone, wishing you all a very good afternoon. I hope all of you are doing fine, fit, healthy, safe, happy as always. Good afternoon, Yarika. And I hope I am audible and visible to all. Good afternoon, Tarun, Abhiram. I am fine, Yarika. How do I look like? Do I look like sad? Do I look like not well? I'm great. I am great. Good afternoon, Tanu. How are you, beta? I'm great. I'm doing great as always. I'm always great in your company. Whenever I'm taking class, I feel good. At that times when I'm not taking class, probably that is the time when I'm not good. Anyways, we start today's class with the same instructions. Keep your mobile that cameras off so that you don't get that dig in the class. Secondly, sit at a place which is quiet and you get good network so that you don't lose network. You come in, come out, you miss a lot of the class and the action. And thirdly, if you have to answer anything, ask, send your messages on the ID of Astic, which you are doing, or on the ID of everyone. Is as far as I remember, the last thing that we were doing was a very typical problem, and this problem has already come in JEE mains twice, I think. And I think we were able to understand the problem that we did in the last class. The problem was this: there was this, what should I say, a basket, and in this basket, this man was kept, and we had to find out the tension in this basket so that the system remains in equilibrium. Do you all remember this question? And do we remember how we solved it? Yes or no? We draw the free body diagram of the basket and we draw the free body diagram of the man and we found out the tension and we found out the value of the tension. Yes or no? Do you understand this? Once we know the value of tension, we can find out the value of normal reaction as well. As you can see, there is a normal reaction N over here, which I am marking right now. We have already calculated the value of tension. We can put this value of tension in any of these equations and we can get the value of the normal reaction. I think we have done enough problems on the part of equilibrium, on the topic of equilibrium. I think it is good enough for you to go on with life. So I will not do more problems. Remember, this same equilibrium problems are going to come again in the chapter on rotation. Whatever we are doing here, is known as translation. Translation. Whatever problems we are doing here are problem on translational motion. The body is in translational motion. There is one more type of motion, or rather two more type of motion that you have to study. One is known as pure rotation. This is pure translation. The other one is pure rotation. The third one is general motion. Now, when you say general motion, any motion can be categorized or thought of as consisting of two parts, or I should say three parts. The first part that we are doing right now in all these chapters up till rotation is known as pure translation. So this is the part that we are doing right now, which is known as pure translation. When we go on to the chapter on rotation, first we will do pure rotation. And lastly, we will do a combination of rotation and translation. We can call this as general motion, which will consist of rotation as well as translation. Now you will say, sir, what is pure rotation? You look at the motion of the clock, the hour hand, minute hand, second hand, or the fan which is making this noise. This is pure rotation. Pure translation is the motion of anything which is moving in a straight line. That is pure translation. Car. the entire motion of the car, or you are sitting in the car, the motion that your body follows is pure translation. Now you can have a general motion where the body can be translating as well as rotating. Imagine the motion of the tire of the car, or tire of your bicycle, or tire of your bike. It is rotating as well, it is moving forward. So that is the combination, the most difficult type of motion, and we will be dealing that motion. Right now, whatever we are dealing here is pure translation, and equilibrium that we had dealt is known as translational equilibrium. The body is in translational equilibrium. In the chapter on rotation, we'll also study about rotational equilibrium. And then we will study and understand that if a body has to be in equilibrium, it has to be in two types of equilibrium. The first type of equilibrium will be known as translational equilibrium, which we have studied now. The second type of equilibrium will be known as rotational equilibrium, which we'll be studying in that chapter. Am I clear? Can I have some raised hands? I hope I have not confused you. I only tried to give you additional information that we are going to do in the coming chapters, which may not have any relevance right now, but it will have relevance when we come out, when we go forward. Can I have this and that we understand this? Vishal, Vasant, Tarun, Tanu, Preeti, Nyarika, Akshara, Abhiram. This is what we are going to do in the coming classes. We'll do something known as rotation, and then we will study each and everything once again. Wait for it. That is the most difficult chapter that you will encounter. Up till now, coming back to what our classes was, we have dealt with translational equilibrium and we have dealt with Newton's first law of motion. But we must understand that equilibrium is not the only condition that we will have to study. By equilibrium, we mean that the body, if it is at rest, it will remain at rest. If it is moving with uniform velocity, it will be moving with the same uniform velocity in the same straight line. In other words, we were talking about the case where the acceleration of the body was zero. The body was not accelerating. But that is not the only case that we have to understand. So now we have to move into cases where the body is accelerating. So the number two type of questions, or the number second type of topic that we'll encounter in this chapter, which will take the most part of this chapter, is accelerating bodies. So now we'll deal with accelerating bodies. The next heading is accelerating bodies. How will we solve problems for accelerating bodies? Now, as soon as we get into the accelerating body, we must remember what was acceleration. What was acceleration? We had dealt with acceleration in the previous chapter. We have dealt that we have seen four types of acceleration. One was known as instantaneous acceleration. One was known as average acceleration. One was known as uniform acceleration. The fourth one was known as non-uniform acceleration. Do we remember all those accelerations? And I have reason that we remember all those accelerations. The first type of acceleration was instantaneous acceleration, and we wrote instantaneous acceleration as a vector, and this was rate of change of velocity of the particle. Yes or no? That was known as instantaneous acceleration. We also did another type of acceleration which was known as average acceleration, and average acceleration was total change in velocity divided by total time, which we can write it as final velocity minus initial velocity divided by time. And then we also saw that acceleration can be constant or uniform. It does not change, so that will be known as constant acceleration. If the acceleration changes, it can change in magnitude, or it can change in direction, or it can change in both. Then that acceleration is known as non-uniform acceleration. Do we remember this? Can I have some reason that we remember this? Whatever we have read about acceleration, do we remember this? Can I have some raise hand that remember this? Instantaneous acceleration, average acceleration, uniform acceleration, non-uniform acceleration. Okay, just note this down. Give me a minute. I'll just fetch my water. I'm just feeling thirsty. Give me a minute. Write down this. I'll be back in a minute. Sorry, my voice was not audible, right? Yeah, so what I was saying was, this is the chapter known as dynamics, right? And in this chapter known as dynamics, what we are going to do is we are going to study the cause of motion. And as I told you, the cause of motion, or what we are going to study, is basically force. Now, once we study force, we study Newton's laws of motion. Now, once we study Newton's laws of motion, we have already studied Newton's first law of motion. Yes or no? Have we studied Newton's first law of motion? Yes or no? Have we studied Newton's first law of motion? Yes or no? Have we studied Newton's first law of motion? No one remembers it? Yes. Can you tell me what was Newton's first law of motion? What is Newton's first law of motion? What is Newton's first law of motion? Newton's first law of motion says that if a body is at rest, it remains at rest, or if a body is moving in a straight line with uniform velocity, it will continue its motion with the same velocity unless disturbed by an unbalanced force. This is Newton's first law. You can call it in different ways. The actual transition is like this: in a state of rest or uniform motion in a right line means straight line, unless it is compelled to change that state by forces impressed thereon. It's in an exact translation from what Newton wrote. So basically he's talking about bodies in equilibrium. What is Newton's second law of motion? Newton's second law of motion. Now, Newton's first law of motion talks about a case where F is zero. There is no force acting on the body. Acceleration is zero. What does Newton's second law talk about? Now, there are different ways in which Newton's second law can be stated, but the way that I'm going to state it, F is equal to ma. This is the way I am going to state Newton's second law. Sometimes it is also stated in the terms of rate of change of momentum of a body, but we'll first try to see the definition that has been extracted from his book, which Newton wrote. And Newton's second law can be stated in this way: the alteration of motion is ever proportional to the motive force impressed, and it is made in the direction of the right line in which that force is impressed. It may look very complicated. It may look very complicated. It is basically saying that F is equal to ma. It is basically saying that F is equal to ma. It is basically saying that F is equal to ma. So how we can state this? How we can state this in a simpler way? Whenever a force acts on a body, the body accelerates. Whenever force acts on a body, the body accelerates. The acceleration of the body is in the same direction as the direction of force. And this acceleration is directly proportional to force. This acceleration is directly proportional to force, or you can write this acceleration as this force divided by its inertia or its mass or acceleration produced in the body will be given by F divided by m, or F becomes equal to ma. This becomes Newton's second law of motion. Whenever a force acts on a body, body accelerates. The direction of acceleration is in the same direction as force, and the value of that acceleration is force divided by mass. Vectorly, I've written it like this. This statement is known as Newton's second law of motion. It defines what is acceleration of the body in terms of force that is applied on the body. Am I clear? Have you written this? Am I clear? Can I have some raise hand that we are clear? Vishal, Vasant, Tarun, Tanu, Preeti, Niharika, Akshara. Do we all understand this? Basically, Newton's second law defines the acceleration of the body. Newton's second law is basically defining the acceleration of the body. Everyone understands this? Everyone understands this? Can I have some raise hand that you understand this, sir? So that I can have more faith that we all understand this. Great. Now, this law can also be stated in a different way. Now, what is that different way? This different way is what you find in books. If you refer S.C. Verma, you will find F is equal to ma. So the first way of writing this Newton's second law is F is equal to ma, which I have already told you. But there is one more way of writing this, where we write it as F is equal to dp by dt. Now, what is this dp by dt? I'll also try to define it. What is this p vector? This p vector is known as the momentum of the body. This p vector is known as momentum of the body. What do you mean by momentum of the body? The momentum of the body is mass of the body multiplied by the velocity of the body. That is one thing which we call as the momentum of the body, mass of the body multiplied by the velocity of the body. What it is telling you, it is basically telling you the quantity of motion. That is how Newton thought about it, or we can also think about it. We want to be like Newton. This can be defined as the quantity of motion that the body contains. Momentum, more often than the mass or the velocity, tells us how much motion is contained in the body. A truck, mass is very big. Velocity may not be so high, maybe 30 km per hour, maybe 40 km per hour. But when this truck collides with something, a wall or another car or another truck, it creates a big explosion. It creates a big impact. It creates a big force because mass is large, even though the velocity is less. The momentum is the quantity of motion. Just because the velocity is less does not mean that the motion is less. It has a large mass. Momentum defines its quantity of motion. How much quantity of motion it has? What is the strength of the motion that it has? You can think it about like this. A bullet. A bullet is very small. The mass is very less, but the velocity is very high, 180 kilometers per hour, 200 kilometers per hour. Sniper bullets are still faster. And when it gets inside your body, it can actually penetrate your body and get inside your skin, your skull. Why does that happen? Even though the mass is less, the velocity is high, and hence it creates a large impact. A meteoroid, you might have heard about meteoroid. There have been some meteoroids that have actually hit Earth, small pieces, not very big, small pieces of rock. But when they hit Earth, they will create a large devastation. I hope it doesn't happen in our lifetime. Why? It's such a small body. Why would it create such a big devastation? Because of the velocity with which Earth and that body is moving with a very high velocity. And it comes, impacts, creates a big wave. Momentum defines the quantity of motion of this body. Mass into velocity. Do we understand it? It is a vector quantity. Momentum is a vector quantity. Momentum is a vector quantity. And it tells us the quantity of motion contained in a body. Am I clear? This is only what we are going to study about momentum right now, because we are going to study momentum in great detail in the coming chapters, next to next chapter. But what has this momentum got to do with force? What does this momentum got to do with force? Anyone can tell me what this momentum has to do with force? Anyone would like to tell me what this momentum has got to do with force? What this momentum has got to do with force? No one? The rate of change of momentum of a body is proportional to the force, and it takes place in the direction in which the force acts. That means what he's saying, rate of change of momentum is dp by dt. This dp by dt, rate of change of momentum, is directly proportional to force, and momentum changes in the direction of the applied force, or dp by dt is directly proportional to f, or dp by dt is equal to a constant k multiplied by f. We found out that the value of that constant was 1, and hence dp by dt is equal to f. That becomes the second way of writing Newton's second law of motion. Rate of change of momentum is equal to the applied force. Do we understand this? Can I have some raise hand that we understand this, sir? So there are two ways of writing Newton's second law. F is equal to ma, force is equal to mass into acceleration. That becomes my first way. Or force is equal to dp by dt. That becomes my second way. If you look at it, F is equal to d by dt of momentum is mass into velocity. In the cases that we are going to do, mass will remain constant. So mass will jump out. It will be rate of change of velocity, and rate of change of velocity is acceleration. So from equation number 2, I can get equation number 1, or from equation number 1, I can get equation number 2. Do we understand it? Am I clear, or have I confused you? Can I have some reason that I'm clear? Vishal, Vasant, Tarun, Tanu, beta, where are you? Preeti, Niharika, I hope your understanding is. Preeti, are you there in the class? Tanu, are you following this topic, beta? Very simple things to understand. I hope you have done it in your ninth standard. Even if you have not done, I've covered everything that you needed to know from your ninth standard momentum, mass into acceleration. I hope this is very clear. Is it? Shall I move on? So this is my Newton's second law of motion. Now, sometimes it is said that Newton's first law is contained in Newton's second law. Now, how you can prove this? It's very simple to prove. You can see this in these important points that are coming on your screen right now. Important points about Newton's second law. The second law is obviously consistent with first law if F is 0, A is 0. So basically, Newton's first law is telling us if force is 0, acceleration is 0. So Newton's first law becomes a special case of Newton's second law. What special case? If in Newton's second law, I put F is equal to 0, if I put F is equal to 0 in Newton's second law, that becomes Newton's first law. Am I clear? Am I clear? If I put force as 0 in Newton's second law, it becomes Newton's first law. And that is why we say Newton's first law is contained in Newton's second law. Have you written this, everyone? Can I have some reason that you've written this, sir? And that we have understood this, Newton's second law. No one understands this? Newton's first law states that if there is no force, body will continue. If at rest, it will continue at rest. If it in motion, it will continue straight line motion with uniform velocity. Newton's second law states that if the body has force, unbalanced force acting on it, it will accelerate, and the value of that acceleration is F by m. If I put F as 0, acceleration becomes 0. Newton's second law gives me Newton's first law. Can I have raised hand that we have understood this? I'm loading all hands. Have you understood this? What I've said? Newton's second law contains Newton's first law. That is the first point. Please write this because this might not be in there in your notes. So you have to write this. Then secondly, I have said that F is equal to ma. This is the vector equation. F is equal to ma. This is the vector equation. We can break it up into three components. The first component will be force along x. So force along x will be m into acceleration along x. Force along y, force ka y component will be m into acceleration along y. Force ka z component fz will be m into acceleration along the axis. That means if you have force applied at any angle, you can find this component along x, you can find this component along y, you can find this component along z. Component along x will give you mass into acceleration along x. Component along y will give you mass into acceleration along y, and component along z will give you mass into acceleration along z. Is this point clear to everyone? Now, this F is equal to ma that we have applied is only applicable to a point mass, where F is the net external force and A is the acceleration of the body. Any internal force are not included. If there's a point mass, point will not have any internal forces. But when you get to the chapter of rotation or to the chapter of center of mass, it is going to come, you will have more than one body. Right now, we'll be dealing only with one body. In the coming chapters, we'll be dealing with more than one body. So these, if there are two bodies, they will have forces acting on each other. They are known as internal forces. So when those forces come, then we will talk about those forces. Right now, we are going to consider all bodies as one body and apply F is equal to ma. Am I clear? Do we understand this? So these are very, very important points that are noted down. Then F is equal to ma is an instantaneous relation. F is equal to ma is an instantaneous relation. That means at any time, whatever is your force, that will be mass into acceleration at that time. It does not depend on the history of motion. What has happened in the past, what forces have acted on the body in the past have no bearing here. What is the force now is equal to mass into acceleration now. What has happened in the past does not have any effect. So these are some very, very important points that you must remember while we are trying to solve any problem on Newton's second law. Do we all understand this? Have we noted all these 4 points? Yes or no? Can I have some raised hand that you have noted these points? Abhiram has noted it. What about the others? You may not find this point in the note that I have given you. Some things have to be written with your own hands, because then only you will remember them. Vishal, Vasant, Tarun, I am not getting any participation from you guys. Tanu, Preeti, are we there in the class, beta? Akshara, you all understand what is happening in the class? Well done. So this is all about Newton's second law. It states F is equal to ma, or F is equal to rate of change of momentum. Now, the question comes, how are we going to apply it? We know how to solve questions on equilibrium. Now we are going to solve questions on accelerated bodies. Don't get confused and don't get tense. The process of solving the question in this case and the previous case are almost similar. We'll have to follow almost the same rules. Just one thing will change, and that one change will be the change between Newton's first law and Newton's second law. That will be the change between equilibrium and accelerating body. So are we ready to write down the steps for solving problems for accelerating body? That is your heading. What is your heading? Your heading is steps for solving questions on accelerating body. Steps. Keep in mind what were your previous steps and see what difference is there. Steps. As you can see, what is the first step? First step, make a sketch of the problem. We have already known that step. You always make a sketch of the problem. That is the first step. Draw the sketch of the problem. What is step number 2? Isolate a single body and draw the free body diagram, clearly showing all the forces acting on it. You should be careful that you draw all the forces acting on the body and not the forces which are not acting on that body. Same principle. We have to draw the free body diagram. Am I clear, everyone? Is everyone there with me up till this step? Can I have some raised hand? Just, sir, we are here. Don't worry, sir. Everything is fine in this universe. We know step number 1. We know step number 2. Can you guess what is going to be your step number 3? What is step number 3? And step number 3 comes right away. Is it anything different? Let's see. Step number 3, choose a convenient coordinate system. Same step. Show location of coordinate axis and all. Resolve all the forces along x and y. You can call this as step number 4, as we said previously. So you have to now assign x-axis and y-axis. I've already told you, if something is kept on a horizontal surface, this becomes your x, this becomes your y. If something is hanging, this becomes your x, This becomes your y. If something is kept on an inclined plane, this becomes your x, and this line becomes your y. Do we understand this? That is choosing your convenient axis. Yes or no? Then step number 4 is there might be some forces which are not lying along x and y. You have to resolve all those forces into x and y. Do we get this? Yes or no? Can I have some raised hands? Yes or no? Now, the only thing that changes, this becomes my step number 5. The only thing that changes, in fifth step there, we were equating all the forces on the x-axis and we were equating all the forces on y-axis. Now, what will happen in this case? First of all, the forces will not be equated. The forces will not be equated. There will be an unbalanced force acting on the body. Now, for example, if a body is kept on a surface, and in most of the cases, the body is not going to move from the surface. So what will happen is forces on the y-axis, in this case, will be 0, but there will be a net force on the x-axis. So what do? You apply the formula net force on the x-axis is mass into acceleration, and net force on the y-axis, it might be 0. So these two become your formula. It might happen the other way around, that you have net forces acting on the y-axis. In that case, what happens is your equation becomes Fy is equal to m into Ay, but your net forces on the x-axis become 0. So this becomes 0. Or it can happen in very difficult cases that you have net forces on the x-axis as well as net forces on the y-axis. In that case, you will have to apply both the formulae together. Do we get my point? In most of the cases, forces along one direction will be 0. There will only be force along the other direction. In very difficult problems, there will be forces along both the directions, and hence you will have to use both these equations. Once you have made this equation, you make the equations for all these bodies. You will have some unknowns, some equations, see the number of unknowns, see the number of equations. If there are two unknowns and there are two equations, you can solve them. If there are four unknowns and four equations, you can solve them. But if there are four unknowns and three equations, something you have missed. I gave you a question, remember. Four unknowns, three questions, something you have missed. You'll have to look for that missing opportunity, find out that missing component, make your equations, solve them, stay ahead. Have you understood what I've said? Step number 1, draw a sketch. Step number 2, isolate all bodies, draw free body diagram, draw all the forces. Step number 3, choose convenient axes as x and y. Step number 4, resolve all forces along x and y. Step number 5, there might be one axis on which the net force is 0. There might be one axis on which net force is not 0. If the net force is not 0, apply F is equal to ma along that axis. If it is x-axis, Fx is equal to m into ax. If it is y-axis, Fy is equal to m into ay. You will have number of equations. You will have number of unknowns. Number of equations must be equal to number of unknowns. Solve them. If the number of equations are less, number of unknowns are more, you have missed the equation. Look for that equation. Find out that equation. Solve it. And we are done. Can I have raised hand that we have understood this? whatever I try to make you understand, I hope you have written. I hope you have written these steps. If you have not written it, I hope you have understood these steps. I hope you have understood these steps and you will be able to put these steps, solve these steps, and get the answers for our questions. Anyone has any problems with this question, with this what I have discussed? Please raise hands. Else we are going to move on and solve some questions based on these things. Are we ready to solve questions then? Are we ready to solve questions then on this? Questions on Newton's second law of motion, NSLM. Are we ready? Can I raise hand that we are ready, sir? Ready? No one is ready to solve questions. Niharika is ready. What about Aviram? Aviram is ready. Akshara, Preeti, Tanu, Tarun, Vasant, Vishal. Are we all there? Okay. Let us get to the simplest possible one. This is a block of 5 kg. The floor is frictionless. Friction will come in the next chapter. Don't forget. Let's forget about friction. I have applied a force of 10 newtons on this. To find two things, find the normal reaction from ground, force from ground, don't forget that force, and find the acceleration of the body. These are the two things that you have to find out. Your time starts now. How are you going to do this? If you can follow those steps, you should be able to get the answer. I will give you a minute or 2 minutes. Think about this question, else I will solve it for you. Yes, Niharika, normal reaction is 50 newtons. Remember, uh, whenever, important note, whenever something is kept on a surface, here, this body is kept on a surface, you must always remember and understand that this body will never leave this surface. It will not move in air by leaving this surface. Obviously, I can make a question where it happens, but that question will be very specific. In most of the cases, body is going to remain on the surface. So body will move along the surface. Remember that. Body always moves along the surface. It never leaves the surface. No one will tell you that. You'll have to always imagine it, understand it. That if a surface is given, if the body is kept on a floor, on a table, on ground, it will always move along the table, along the ground, along the incline. Anyone got an answer? Niharika has given me the answer for normal reaction, but I also need to find the acceleration. Okay, so I will help you out. Aviram, did you get the answer, beta? No? I'll help you out. How to solve this problem? First step, draw a sketch. Sketch is already there. Isolate all bodies. There's only one body. Draw the free body diagram of this body. Let us draw the free body diagram. Red color. Weight mg, which is 50, is downwards. It is kept on a floor. The floor is pushing it upwards. One more force, 10 Newton. Let me call this Newton. Let me take out this Newton, otherwise N and N will clash. One force of 10 is acting on this direction. Now, I will So I've drawn the free body diagram. I have to choose convenient axis. What are the convenient axes here? Everyone knows that this must be my y-axis, and everyone knows that this must be my x-axis. Now, as I told you, the body is kept on a surface. It is not going to leave this surface. If it is not going to leave its surface, it will remain in equilibrium. That means these two forces, the yellow one, which are along y-axis, these two forces will equate themselves because the body is not going to fly away. Do we understand this? Can I raise hand that these two forces, the body is only going to move along x-axis? Everyone understands this? That the only motion that is possible here will be the motion like this. The body is going to move like this. It is not going to move up and down, and hence the forces in the up and down direction, which is the y-axis, must equate. So I have my first equation, N is equal to 50 Newton. So I get the first answer from the equation along y-axis. Now let us look at equation along x-axis. There's only one force here. There is no force on the backward side. So it has to move forward. Let me call the acceleration as A. Let me call the acceleration as A. So the acceleration is A, which is green thing here. The only force is 10 Newton here. Acceleration is along x, force is along x. What is the equation I will put here? I will just put F is equal to ma, net force is equal to ma. Net force is 10 Newton. Just write net force here so that you remember that you have to find out the net force. Net force is equal to ma. Net force is 10 Newton is equal to mass is 2 into A. That gives me A as 2 meter per second square. That is the equation that I have made for x-axis, and that gives me the acceleration of this body. Do we understand this? How I have done this? I've applied the same concept. I've applied the same step. Only one step has changed. That is the last step. That is the step of this green thing where I've applied, or green will not look good on green, so I must do it blue. That I've applied F net is equal to MA along x-axis. That is the only thing that has changed. Apart from that, all the steps are exactly similar to what we had done in the previous classes. Shall we move ahead? Will you be able to do the next question? How the mass is 2? Oh, I've taken it wrongly, beta. Thanks for rectifying me. The mass is 5 kg, so the answer becomes 2. The answer was correct. I wrote it 2A. Sorry. Okay. Am I clear with this? Okay. Now, I gave you one question to solve. This is 10 kg mass. One force, 50 Newton, is acting like this. One force, 30 Newtons, is acting like this. You have to find the normal reaction and acceleration of the body. Your time starts now. Normal reaction is 100. Yes, Niharika, that is correct. Can I have the answer for acceleration? Anyone? Can I have the answer for acceleration? Anyone? I'll give you 1 more minute. Okay. So how I got to solve this? Yes, Abhiram, acceleration is 2 meter per second square. That is correct. How do I solve this? First step, draw a sketch. Already there. Second step, isolate all bodies. Already isolated. Third step, draw the free body diagram. So the weight is 100 newtons. Normal reaction is N. Assume two axes as convenient axis. This is my Y, this is my X. Body is kept on ground. It is not going to move up and down. So I get my equation along y-axis. What is my equation along y-axis? N is equal to 100. That is my equation along y-axis, equation of equilibrium. I don't have to do anything here. Now I have to imagine how is this body going to move. See there, this side the force is 50, this side the force is 30. If both the forces were same, the body will remain in equilibrium. But here the forces are not same. One force is more, other force is less. Where will it move? Everyone understands that this will move. Oops, wrong color. What happened? This body will move here. Let me call the acceleration as A. Let me call the acceleration as A. So what will be the equation? Force net, F net is equal to MA. This is the equation I am going to put along which axis? Definitely x-axis. The previous equation was along y-axis. Now I put the equation along x-axis. What is the net force? 30 is here, 20 is here. So the net force becomes 50 is here, 30 is here, 50 this side minus 30 the other side is equal to mass. Mass is 10 into acceleration. From here I can get the acceleration as 2 meters per second square, and that is my answer. My acceleration is 2 meter per second square, and my normal reaction is 100 newton. 100 newtons. Am I clear? Can I have some reason that we understand this, sir? Niharika, Abhiram has understood this. What about the others? Akshara, Vishal. Do we understand this, beta? Everyone. Can I give you another question now? And it's not getting changed. Just a moment. I'll have to wait. Let's see. Up till now, what we have done? Okay, we have done this question. Pen is not getting changed. Okay. So what I'll do here, I'll go to this slide and I will go here. I'll give you the question here. Meanwhile, I'll sort that thing out. So, question number 3. Now I have block like this. I've kept a block. Let me call this as 5 kg. I've applied a force of how much? Let me apply a force of 10 Newton here. This angle is 37 degrees. I've applied I have applied a force of 2 Newton on this side. Can you see it now, beta? You have to find the value of normal reaction and the acceleration of the body. You have to find the normal reaction and the acceleration of the body. Can you do this? You have to find the normal reaction and acceleration of the body. Normal reaction and acceleration of the body. Anyone? How will you do this? First step, draw a sketch. Sketch is already there. Second step, isolate all bodies. Isolate it. Third step, draw free body diagram. Let me draw the free body diagram. This will be 50 newtons mg. This will be normal reaction n. Next step, assume two axes as coordinate axis. This will be my y-axis and this will be my x-axis. Yes or no? So far so good. Do we agree on this? So far so good. Anyone has any doubts up till here? Okay. Now what do we see here is that this 10 Newton is going like this. So I'll have to resolve it. How will I resolve it? This is 10. This is 37. So this becomes 10 cos 37. Cos 37 is 4 by 5. 10 multiplied by 4 by 5. 10 multiplied by 4 by 5 becomes 8. So the force in this direction becomes 8. Do we understand this, everyone? This is 10. This is 37. So this becomes 8. As soon as it becomes 8, the other one becomes 10 sine 37 and 10 sine 37 is 6. So in this side it is 6. Oh, sorry. This side it is 8 and this side it is 6. As soon as you do this, you have resolved the force. You can now take this force off because we have already resolved it. Do you understand what I have done here? Can I have some reason that we understand this, sir? 10 Newton has been resolved into 8 and 6. Now there is no need of this 10. That 10 can be taken off. Now the body is kept on a surface. It cannot move perpendicular to the surface. So upward forces and downward forces in green, which is my y-axis, upward forces must be equal to downward forces. Do we all understand this? N plus 6 must be equal to 50. That implies N will be equal to 44 newtons. Every one of us understands this. Please raise your hands. N is upwards, 6 is upwards, 50 is downwards. It cannot move in this direction. So N plus 6 equates 50. Can I have raised hand that we understand this, sir? Vishal, Akshara, Vasant, Tarun, Tanu, Preeti. Do we understand this, beta? Now what is left? Is the forces along x-axis. On x-axis, on the right hand side, I have 8, which I am marking right now, 8. On the left hand side, I have 2. 8 is not equal to 2. 8 is more than 2. That means this body is definitely going to go this side. Let me call the acceleration as A. The body is going to move like this. Let me call the acceleration as A. Now I will apply F net is equal to ma, and this equation will be applied along which axis? Say beta. Will be obviously applied along x-axis, sir. No problems. 8 is this side. 8 minus 2 is this side. 2. 8 minus 2 is equal to ma. M is 5. A is A. 6 equal to 5a. Acceleration becomes 5 by 6 meter per second square. So this is the answer that I was looking for. Do we get this? Can I have some raise hand that we understand this, sir? I'm loading all hands. What have I done? Nothing special. I've only done what we are doing since the last 2-3 classes. Draw a sketch, draw free body diagram, draw all the forces, find convenient axis, resolve the force along convenient axis. Along one direction, the body may not move. Equate the force. Along one direction, the body may move. F is equal to ma. Newton's second law of motion. We have done questions on Newton's second law of motion. We'll continue with this Newton's second law of motion in the next class. Same concept. In the next class, we will not have just one body. We'll have more than one body. Then we will see how we can apply Newton's second law on those bodies. Nothing is extra we need to do. Instead of one body, we'll have to do it for 2 bodies or 3 bodies or 4 bodies. We'll do in the next class. Don't worry about anything. I am here. You are here. God is there with us. Everything is going to be fine. I'll meet you in the next class, day after tomorrow. Until then, I hope that you remain safe, healthy, and happy. See you tomorrow. I mean, day after tomorrow. The next class. If you have any doubts, you can ask me. Bye bye.